Cool. Hey, this is Logan with Flex Machine Tools. I have Aaron here with me as well. He's our programmer, going to be running these demos. But I also wanted to introduce Kevin Meyer with Allied Machine and Engineering, as well as Mitch Ray with Flow Drill. They're going to be our tooling experts on a couple of our demos that we're running here for Gladwin Machinery. It was initially going to be a on-site demo, but with everything going on with COVID-19, obviously that's not really an option right now. So we're doing what we can, doing some social distancing, and we're going to run this here for you. We've got 4 demos we're going to run. We've got a demo to show off some of the high-speed milling and infinite look-ahead on our controller. We're going to be doing some flow drilling. We're going to be talking about a couple different types of tooling from Allied Machine and how they fit in for different applications, as well as a demo showing some drilling and some slotting as well, and some tubes. So I'm going to get Aaron started here on this one. This is our standard hex block demo that we do quite often. It really showcases some of the high-speed milling that the machine is capable of. Yeah, I'll show you the block. This is what the finished part is going to look like. So this machine specifically is our G-Series 2004, which means 20 feet on the X-axis and 4 on the Y. It also is kitted up with our high output package, which includes the ZF gearbox, as well as the Cat 50 spindle. The ZF gearbox allows the machine to put out about 400 foot-pounds of torque and up to 22 horsepower to the spindle. Do you have the controller that you can throw up there, Isaac? We'll show you a video there on the side of the controller running through the code, which, again, as you'll be able to see here, shows how quickly it can run through this code. It's got infinite look ahead, which allows for really smooth high-speed milling, 3D tool path, circular interpolation, helical milling. So Aaron, I'll let you describe a little bit as to what the demo is actually doing, what material it's in, what kind of tooling is on there.
Yeah, so this is 1 inch by 2 1/4 1018 steel. Right now we are running a 1/2 inch Kennametal Harvey 1 end mill. We're taking a 100,000 step over. Our RPM is 3,900 and we're feeding at 39.5 inches a minute. So Isaac has the screen pulled up of our software, and as the tool runs through the program, you can see the red line that's kind of dropping down below the highlighted line. That's the infinite look ahead that Logan was talking about earlier. And what allows that machine to do is essentially read what's coming up. So it makes all of the arcs and curves move a lot more fluently through the program. And
yeah, so I mentioned that this machine specifically is the 20 foot by 4 foot. Our standard bed frame is 20 foot by 6 foot, which is then 6 foot on the Y-axis. Really, we can make the machine as long as you need to for your parts. Obviously, this part here is a smaller part where, the machine, it usually immediately appeals, to those with much longer, more cumbersome parts that maybe you have to do some refixturing, in a smaller VMC, or maybe you're doing it by hand. But this just shows that it can also do small parts, more complex parts. And you can even zone the machine out if you'd like. So say you've got a 10-foot part that you're running a lot of, but maybe you're running these parts quite often as well. You can have part of the bed dedicated specifically for these smaller parts, already have devices in place, the program loaded up in the machine, and then you can run it on what we call Pendulum Processing. And what that allows you to do is while it's maybe milling and drilling on this part, you can be loading and unloading parts on other areas of the machine. You know, as many really as you can fit on within the light curtain barrier that we have here, that I can show you here in a minute when this part is completed. But what that allows you to do is those light curtains is a safety barrier. So as long as you do not obstruct that light curtain, the machine will be running essentially with 100% spindle uptime and eliminating all of your refixture time that you'd need on a traditional smaller machine. So I've actually, I had a conversation with an individual the other day, and they had mentioned that for a while they thought the pendulum mode, as they were looking at the machine, was really just cutting the machine in half and using one side and then the other side, you know, as the pendulum swings back and forth. But like I mentioned, in reality, you can set up as many zones as you'd like, as long as the machining zone can be within the light curtain and you can be working outside of that. Yeah, so on that video there, that gives you an example of the pendulum mode. So you can see, obviously it's really quick when he goes in, moves the light curtain, changes out the part. But that just gives you a good example as to the machine really never stops, aside from the rapid travel from one part to the next. So this is the light curtain I'm talking about, but it runs along the machine here on these rails. And as long as you are on the outside of this light curtain, you can do whatever you need to on the portion of the bed that's outside of it. And it will keep running. If you do break this curtain, it'll slow the machine down to 10%. And then if you do not get out of the way within a certain period of time, then it'll stop. Rapid speed is 1,000 inches per minute on the X and the Y. We'll give you a look inside the window here. So too, another thought with the machine, obviously you can see there's a lot of area left for the machine for fixturing. You know, I mentioned pendulum mode, but with the bed width on this machine, you could fixture several of these across the bed width on the Y-axis, and it could be doing its cycle on all of them, you know, in the same program as well. So you're not limited to just a couple. You could virtually fit as many on the bed as you'd like to. Yeah, it is an auger. The chips fall through the bed here. I'll have the camera show a quick look. The auger then pushes the chips into the chip bin, and then the coolant is recycled. You can get a tiny look there. It's kind of hard to get it with the camera, but the auger is going and pushing those chips down the machine. And also, guys, you'll see there on the right side of the video, there is a chat box. If you have a question, definitely just sign in. If you have a YouTube account already, that will give you the ability to sign in and type in a question. We'd be happy to answer them for you. And if any of you have answers already in the chat, feel free to chime in and help out. But yeah, we'd love to hear from you. What questions you have, comments. So Aaron, we just got a couple finishing passes here, correct?
Yep, that's what we're doing right now. We finished the 2 slots, the inside bore. We are finished, or I'm sorry, the 2 slots, we're finished in the outside of the hex right now. And then once this is done, we will do a finish pass on the bore in the center. So I'm going to show up this part here if you guys can take a look at it. So like I said, how we roughed out the outside here was with that high-speed tool path that I talked about earlier. And then the 2 slots, what we did was I pre-drilled the corners of the slots. And then I'm going to throw out a Mastercam term here. This is what I used to program it. I contoured or ramped the slots. So essentially what I was doing is as I was going down into the part, I'm following the contour of that slot. Essentially, as I did the same thing on the inside bore, I pre-drilled a hole to give the chips somewhere to go as I was machining it, and then did a helix bore down through the center there. And then, as previously mentioned, what we're doing right now is we're taking the finishing passes on everything to make everything look nice and pretty.
And so there you'll see a simulation of this part running as well that we put together. And this is a good example of something that we can provide any of you. If you have a part that you'd like to see a time study on to see what kind of cycle times you're looking at for the machine, as well as maybe a visualization as to what the tool pass will actually look like when it's running, obviously before it runs, then we could provide that for you as well. So that was a good example of that.
About rigidity with this cut right here.
Yeah, so that question there, how is the rigidity of the machine? Do you have examples of cuts you have made? Well, this hex block being one of the examples, and like Logan had mentioned earlier, this is a Cat 50 machine. The rigidity of the machine, it's all kind of based off of also what you're doing with the tool. If you want to make sure you're using a nice stubby holder, the shorter the better. To make your tool as sturdy as possible, and same thing with your setup. I had this hex block fully clamped in that Kurt vise, so I'm keeping the part as rigid as possible. And same thing with the tooling. And like I said, we were taking a 100th step over for a 1/2 inch end mill, so we were taking a fairly hefty cut. So yeah, the rigidity of the machine, everything's there. It's a lot of it's based off of your tooling that you're using. So I'm gonna go ahead, Isaac, if you want to pull up Kevin, we're gonna get the Allied demo set up here. And Kevin, if you can hear me.
Yeah, I can hear you.
So the first demo that we're gonna get set up is the Gen 3 XT Pro.
Okay.
If you want to go ahead and talk about that.
Sure, I can talk about that. The Gen 3 that we're getting ready to run in, I believe he's going to be setting up some 1018 blocks. The Gen 3 XT Pro is our newest high penetration drill. The drill is capable, it goes from 11 millimeter up to 35 millimeter is the size range. This drill, we're using our steel geometry here since we're running in 1018, but we do have it in aluminum geometries, cast iron geometries, and structural specific geometry. So I believe a lot of you are structural end users, distributors on here today. We do have structural specific sizes for the Gen 3 and also our TA line of drills. The Gen 3 is really good for high penetration, good rigidity setups, where you're wanting to maybe hold a little bit tighter tolerance. I've got Gen 3 applications where we're holding plus or minus 2 thou. So if you can actually do that in just a drill. If it's tighter than that, you need to drill and do some sort of finish boring. But that's kind of gives an overview of the Gen 3. And I do want to expand a little bit on Preston's question about the rigidity of the machine. I can personally testify that we've ran 3-inch diameter holes on this machine before from solid. Machines can handle it just fine, and we are going to be doing some testing to open up those holes to 4 and 5 inch. So I personally believe the machine's got the rigidity to be able to put in really large diameter holes. So if you want to go ahead with the demo, Aaron.
Yep. Just getting my tool pulled up here.
Okay.
So before I run this, so like Kevin said, this is a 1-inch 343 drill. We're going to be pushing about 450 or 400 surface footage at about 12 thou per rev. So that equals out to 1137 RPM at 13.6 inches per minute. And we'll get this thing started.
And all of these demos too, we're running them in steel, but we do have a 12,000 RPM spindle option for aluminum applications as well. So the machine, yeah, it really shines in steel, but we're also fully able to run aluminum applications as well.
You can hear that tool, how quiet it is. That's a the Gen 3 is a balanced tool. It's a double effective cutting tool. So obviously with the balanced forces, it really keeps the noise level down with the drill.
So I'll have Logan show one of the blocks from this drill, and I'm gonna go ahead and take this tool out so we can show you guys what this tool looks like.
And Aaron, there is a question on the screen. Would you mind touching on the subroutines?
Can this machine run subroutines? Yes. So this software kind of mimics the FANUC controller. So as far as your programming goes, you can use a your local call routines, just like you would on a FANUC controller. Here's the Gen 3 drill here.
Yeah, as you can see, that this drill, obviously it's got a point to it, and it's double effective. What I'm saying, both cutting edges cut out to the margin is what I mean by double effective. So that's what creates the balance on the tool.
So now Aaron's going to be setting up the next demo there for the other drill, and Kevin, maybe hit on the importance of selecting the correct tooling or the correct drill for the application, and what kind of benefits you get when you can maybe narrow down the tool selection.
Right. There's a lot of variables that go into picking the right tool. Obviously, here we've got a really rigid setup. We're wanting to show the high penetration capability of the machine, so that's why we've got the Gen 3 running right now. We do have TAs, which is our one of Allied's original style of drills. With the TA, we've got it available in super cobalt, up through carbide, several different grades available. To be able to say that one drill is always going to work in this application is not necessarily the case. There are all over the country, all over the U.S., all over the world, really. There are guys like myself that work for Allied, and we would come in, we would help you select the right tools for your application. So we would just need to know where your location is. We'd put you in contact with the Allied rep, and we'd be able to figure out exactly what you need. In some cases, you need just super cobalt. Some cases, you want carbide. And depends on the flexibility you're looking for in tooling too, as to what the right fit would be for your application. What Aaron's getting ready to set up right now is our Vortex drill, which is our IC line of drills. In this style of drill, you have two different inserts. You have a central insert and you have a periphery insert. They are the same insert. You just rotate the insert 90 degrees if you're taking it from the center pocket to the outward pocket. So you get 4 edges of cut out of this drill. But this is a single effective cutting tool. This tool is meant for It really shines if you're in some interrupted cut applications, less rigid applications, because you are going to run a lighter feed rate with this style of tool, being that it's single effective. You'll run higher speeds and lower feeds with this style tool. You will get a little bit more noise out of this tool just because it is a single effective, especially in like the 1018 that we're running today. If this demo was being run in a 4150, it would be completely quiet, just like the Gen 3 was, because it's a harder steel. And softer materials, single effective tools tend to squeal a little bit. It's not really a chatter; it's more of kind of like a high pitched squeal. You'll get in a 1018s, your stainlesses. It's a noise to be expected.
Perfect. And to answer your question, Preston, yes, it can be upgraded to 24 tools. And then on the Cat 50 option, it can be upgraded to 20 tools in the automatic tool changer. As far as the spindle speeds, right now, the max speed we have is the 12,000.
So you're getting quite a bit more noise here. Part of the reason we can hear it so well is because the machine is open on the two ends. You do have the curtains there that keep the chips from flying around, but essentially the two ends aren't open. You tend to hear that noise a little bit in this application.
Yeah, so we do sell the pneumatic devices as well, Nathan, and we can actually show you an example of these. They can also be programmed to open and close in the machine program. So there'd be no need to manually open and close all of these vices. Maybe you have a 10, 15 foot part, the amount of vices that you're gonna have, the refixturing time, would be pretty substantial. So these can all be, like I said, programmed to open and close. So you have a square tubing and you'd like to flip it, run some stuff on the other side, you just come over, flip it, and then they would all close automatically too. So it'll save a lot of time. We do have also a multi-vice insert that could, maybe you have some aluminum extrusions or some smaller square tubing. You can have that fixture 5 of those at a time as well. So saving a lot of time.
Show that part that we just finished.
So here's the finished part from that Vortex drill.
There we go. Now we can see it.
There we go.
So you can see it's even though we were getting that little bit of a high pitch, it's still a really nice finish that you're getting down the sides of the part.
Now, Kevin, while I'm setting up this next demo for our flow drill, I know one of the questions that popped up the other day was like the different applications for this Vortex drill. As far as here we just drilled 2 single holes in this block, but what other applications could that Vortex drill be used for?
The Vortex is really good. Like if you wanted to take that part right there and put a 3rd hole right in the center of it, and then you could move over and drill out, the area in between the holes. So you're doing like a pocket. Like if you were doing pocket milling, you could rough it out with a tool like this. Takes interrupted cuts very well. You just got to slow your feed rate down if you're in a heavy interruption about 50%, but you can run the same speed. Tool's really good for interrupted cuts. You can do half holes with it, where you drill a solid hole, move over, and do another half hole. Design to the tool really lends itself well to doing interrupted cuts.
Great. Yeah, and Preston too, we do have IOs on the machine, inputs and outputs, to where, if an integrator or I believe, Gladwin has a couple of guys too that could help you out. If that's something you're looking for, you definitely could. That is not something that we typically provide, as an option, but it is an option if you have somebody that can help you out with that. So yeah, thanks a lot, Kevin. If there's any questions in the chat, maybe we'll bring you in here, but we'll move on to the flow drill application, and we'll bring in Mitch Ray from Flow Drill. Mitch. And while Isaac's pulling Mitch up, maybe Aaron can answer this question here. Have you tried running code based off a FANUC post on the machine? And do you guys offer a post for this machine?
Yeah, so the post that we use for all of these demos right here, I programmed off of my Haas post and Mastercam. Now there are some FlexCNC specific codes, like our coolant pump has a variable pressure. So instead of just giving your machine an M8 for your flood coolant, the first thing you want to do is call out your flood pressure. Before your M8 code, it would be like an M8.1 if you want low pressure, or M8.4, which is our highest pressure. But just simple codes like that we integrate to our machine. But yeah, like I said, I posted off of Mastercam just using my Haas post for our other Haas machines that we have here. Yeah, it was a good question.
Perfect. So yeah, Mitch, we've got Mitch right here with Flow Drill. We're going to run a part here, and while Aaron's getting this set up, Mitch, you want to tell us a little more about Flow Drill, what thermal drilling is, what kind of applications are good for it, and just talk a little more about what kind of benefits it provides.
Sure. Just a little background on flow drilling. It's an alternative to some of the common fasteners out there, be it rib nuts if you're using those, weld nuts. It's a cost savings alternative. It's very environmental friendly, as we don't produce any chips with our process. We provide a bushing once we're all finished with the operation. The bushing is going to be 3 times the original wall thickness that you guys start with. So instead of putting the insert into the part or a big nut, you can use the parent material, and you're gaining 3 times the original wall thickness that you start with. So you got an 1/8-inch material, you're going to end up with 3/8 of thread when you're all said and done. The flow drill process, it works in malleable materials. We do mild steel, stainless steel, also works in aluminum, copper, and brass. We do a lot with the automotive industry. That's the industries we're in, with a lot of the DP materials and the 15 and 1700 MPa automotive materials. As you can see there, our cycle times are fairly quick. We run between 3 to 6 seconds typically. The flow drill is offered in any UNC, UNF, metric, NPT, virtually any thread size that you need. We'll have a flow drill made up to that size. Bit life that we see ranges from material, but in this situation here that the guys are demoing today, we'll easily reach 8,000 to 10,000 cycles with that particular flow drill bit. And I think they're showing you a 1/2-13 in this demo today. We offer 2 styles of bits with the flow drill process. Our standard one that's shown here today leaves what we call a collar on the top side of the material. It looks like a little washer, if you will, when you're done with the operation. Our second option for you guys would be a flat style bit, where instead of the bit that you're seeing there on the image, we incorporate 2 cutting edges onto the bit as opposed to the shoulder there. And what that does is removes all upflow material and creates a nice flush surface, almost a spot face on the top surface for you. Maximum material thickness is about 3/8 of an inch, all the way down to, say, 15 to 20 thousandths of an inch wall thickness. The general rule of thumb we have is half of the bit diameter equates to the maximum thickness for that specific size. So today they're running a 1/2 inch. We could easily go through 1/4 inch wall thickness and still form the 3 times bush length. The nice thing that I've noticed about the FlexCNC is for our handrail and manifold customers, where they're doing longer lengths than normal. I mean, if you've got a standard machining center of, say, 40 to 60 inches, you're having to shuttle that length of tubing down, 2 or 3 times to finish. With the FlexCNC, you set it up, you got one operation, so less chance for errors, less setup time, and so forth.
Yeah, so Mitch, I'm gonna step in here real quick. I'm gonna have Isaac pull up the the screen of the controller here. And the one thing that I want to highlight with using this tool is this G77 cycle right here, which is our form drilling cycle. So what you're seeing here, the Z is the final depth that we're taking this tool down. Now each section here, so the U and the I is, the U is the depth that we're going, and the I is the feed rate at which we're running it. So as you can see, the deeper we go, the faster we go. And then the F 15 inches per minute here is what our final depth is. Now, with the two different styles that Mitch was talking about here, the one that forms the head, I guess, on the part here, we're running that at a slower feed rate to, you know, form that nice and even. And if we were running the other style to shear that off, our final feed rate here would be a little bit faster. Now, Mitch, I'm going to put you on the spot here. Can you explain why this particular tool, you know, we're separating this by different depths and different feed rates? Why are we doing that?
Well, we want the material to heat up. We want to put heat into the process. This is a thermal process, if you will, so it's based on friction and pressure. So we initially want to have a little bit of time. Now it's just seconds, but we want the material to heat up to accept the pressure that we're putting behind it to form that friction. So we start out relatively slow, typically 3 to 4 inches per minute, and progressively get faster all the way up. And like Aaron was saying, if we switch to the flat style bit, we want that last little step to be much quicker in order to create a single chip in the less revolutions as we can possibly get. So as that comes down, it swings a nice chip away from the part. And that's the only time the flow drill process will create a chip, is if we are using the flat style flow drill bit. And typically that's seen just on the top side. You still will not have any debris on the inside of your tube.
And two, what you guys will see here is there on that flex hose, you can see it spraying out paste. It's a little bit different than, you know, your typical coolant. The paste is primarily for applications very similar to flow drill. So there are different options as well for the machine outside of your standard through spindle coolant and flood coolant.
And we certainly don't want any type of water-based lubricant used with the flow drill process or the operation. So what we'll do is use our lubricant that we're spraying on today that you see there. But no water-based coolant or any type of water-based lubricant.
Yeah, and you will see here too, when it gets a little further in its cycle, that we will be form tapping these holes. So like Mitch was saying, it eliminates the need to weld a nut to it. You can just tap the material that it forms inside that tube. And really the benefit too on something like this, like Mitch was talking about, with this directly related to the machine, is it is really great for like handrails for stairs. You know, we've actually had a customer that is using the machine specifically for that application. And previously, you know, they were having to refixture their parts over and over just to be able to achieve all of those flow drills along those long parts, to where now they can set it up and it's just one fixture. They fixture it once and the part's done. So, you know, the cycle time went from, you know, being able to run maybe a few parts a day to being able to run, you know, several parts a day, maybe a few parts per hour.
The nice thing with the form tap that you'll see here in a minute, again, there's no debris or chips inside the tubing. The form taps are stronger. We can run them faster, and you certainly get a lot longer life out of it than most cutting taps.
Perfect.
So what you're seeing here is the spindle is orientating to position before it goes down into the hole.
And something to think about too, guys, is If you're really pumping through quite a bit of, quite a few quantities as far as volume, then, we also have the tapping arm, the FlexArm tapping arm. If you want to cut down your cycle times, you can always pull this part off while, the next part's being done, or you're running pendulum mode. You can, or even leave it fixtured, pull the card up with a FlexArm on it, and tap it offline, just to eliminate some of that cycle time.
We'll run a coolant. Ask Mitch about running oil.
Yeah, so Mitch, as far as form tapping goes, we obviously have different lubrication options, but what's your input on running an oil spray?
The oil's important. I mean, the coolant works fine for mild steel, but if a customer, especially the hand ramps, a lot of those guys are using stainless steel. So we like to utilize oil. It's more important with the form cap to lubricate it as opposed to keeping it cool. So the oil, especially in stainless steel, we see works better. But again, in mild steel or aluminum applications, the coolant is just fine. What some people are doing, instead of taking advantage of the actual spray system that you guys are demoing today, they'll just set a little canister of oil on the table itself, and in the program they'll come over, dip into it, and then go back to run another series of holes. So, like I said, mild steel, the coolant works fine, but for stainless steel, we would probably recommend an oil.
Yeah, and two, and maybe you touched on this before, Mitch, but the part of the idea behind the flow drilling as well as form tapping is there's a lot less material that needs either ran down the auger with chips. It's just a lot cleaner, and you don't have a lot of excess material being cut.
Exactly. It's very environmentally friendly because unless you're using the flat style flow drill bit, you're not creating a chip in either process, the tapping or the drilling, which makes it really nice. You don't have a lot of debris at the end of the day to clean up, or some cases none at all to clean up.
So here's the part we just ran. As you can see, we just did half of it as far as just to be conscious of time. But you can see the paste here, and flow drilling is just a really great option. Maybe Mitch, how would somebody get in contact with you guys to talk a little more about flow drilling and maybe if their application's a good fit?
Yeah, you can contact us by email at info@flowdrill.com or mitch.ray@flowdrill.com. You can give us a call here at the office, 636-548-8485. We'll be happy to answer any questions, or we can do sample work for you if you want to see it firsthand in your actual part. Or if once the quarantines are over, hopefully soon, we can make appointments and then do a demo at your location. Or we can work with these fine guys here at FlexCNC and work together with them to do a demo for you.
Yeah, absolutely. We're happy to do demos here as well. On the machine with your tooling, it'll be perfect.
Yeah, perfect.
Awesome. Hey, thanks a lot, Mitch. Like you said, if you have any questions on the FlexCNC, or I guess the flow drilling, contact Mitch. He'd be happy to help you out.
Absolutely. Thanks, guys. Appreciate it.
Yep. Have a great day.
You too.
So moving on, I did want to address the question too there on the pneumatic clamps. This one here specifically is a 24-inch opening, but we can custom build clamps to be as wide as the machine. So whatever size you require, we can make happen. Now, if you need a 6-foot clamp for whatever reason, we can make one for you. So Aaron's getting this next demo set up here. Aaron, would you mind describing what we've got going on here?
Yeah, so we're just going to showcase the same drill that we showed in the hex block. It's an OSG Mega Muscle drill. We're just going to poke some holes in a tube, and then I know a lot of you fabricators are putting in slots in tubing, so we're going to do a couple slots as well.
So while this is running, Mitch did bring up a great point about demos. Those provide a lot of value for all of you to prove, give you confidence in the machine and the tooling. And that's something that we are very happy to provide. If you are interested in seeing a demo ran specifically on your parts, obviously reach out to us or Gladwin Machinery. We'd be happy to get set up. A great first step to getting to that point would be send us over some part drawings. Get those to your local Gladwin rep, and we will run a time study analysis for you to give you a great idea as to what kind of cycle time you're looking at. We do a really great job at getting those over and running through the details as well. And we can provide a simulation kind of like you saw before, like I mentioned. So like Aaron was saying on this demo here, he's putting some slots in the part. We have a lot of customers that are putting in long keyways as well, which can significantly decrease their cycle time based on how they're currently doing it, especially if their current machines are outdated and the operation is fairly cumbersome. But you'll see here how it does some of the milling as well to create some of those slots. But again, the machine, we're running these smaller parts here. I guess in this certain circumstance, you can use your imagination and imagine this part being 15 feet long, 20 feet long, even 30 feet long. Whereas, traditionally, maybe you're using a mag drill or you're having to refixture this part in a much smaller machine. Obviously, this eliminates the need to do so. So are there any questions that we can address while this part's running over anything that we've gone over so far? Good. So too, another question that may come up as well is currently the standard Z travel on the machine is 20 inches. And some of you may say, well, I have a part that is 24 inches or something along those lines. Maybe you're facing off a weldment or drilling into a weldment. We can actually raise the gantry to allow for taller parts, or depending on the application, maybe lowering the bed is a better solution. We're happy to work with you on that, and we can surely provide a solution for some of those more complicated applications with taller parts. And as far as the fixturing goes, I know here you see, we had that pneumatic clamp there on the end. We've got Kurt Vices here. Some applications require more fixturing work than others. We are happy to provide that as a solution as well. We have a great team of engineers here that provide custom fixturing solutions all the time. And part of that can be involved with our FlexCare package that we actually offer. So,
hey, Logan, real quick. So one thing I forgot to mention, what we're doing here is I'm using a 1-inch spots drill that can double as a chamfer mill as well. It's a carbide insert drill. This particular one is double-sided. So I got 2 cutting edges on this tool, so I can use it as a spot drill to either pre-spot drill holes. What I'm doing here is, because I use a carbide drill, is I'm just going back over the hole to put a nice little chamfer on it. And then on the slots, I'm going to put a chamfer on it, using it as a chamfer mill as well.
Yes. So too, he was talking about the the chamfer. We obviously Tooling is, like Kevin was mentioning earlier, tooling can be a pretty important selection when you're going through that. And this is an example here, and Isaac can throw up a video of this part specifically. We eliminated quite a bit off the cycle time just by using a combo tool, a drill and chamfer tool, so it can do both at the same time.
Hand me that part right there. Here's the tool that we use for that.
So this is the tool that we use for that. And here, and you can see the video now.
So this is the tool that Logan's holding here in the video that you're watching. It's a Gen 3 insert, just a smaller version of what we ran before. And higher up on the tool, it's a combo tool, and it's got another carbide insert there that you use to go deeper into the hole to put a nice chamfer on the hole without having to go through and use a different tool, do another tool change. So, you know, if you want to cut down on cycle time just for your chamfer tools, you know, the tooling that you're using plays a big part in that.
Two, I did want to mention, we have a 4th axis solution as well. So say you have round tubing, and again, this is a smaller portion of maybe something that's 15 feet long. But as you can see, you can chuck this in our 4th axis, and it will index this part. So there's no need for refixturing. And you know, again, something that's really large. This would be difficult to do with, you know, manually or using a drill press, just due to the fact that, you know, it's round and you have to line this back up in your fixture correctly. And so yeah, I mean, again, we'd be happy to run any demos that you have. And here's the part here that we just did. Show some of the drilling, milling capabilities. So yeah, so as far as going back to the program we offer for FlexCare, if I know many aren't really well versed on the programming aspect of the machine, maybe that's something that they're hesitant on. You know, we noticed that, and something that we can provide is assistance in programming the part. You know, we can provide more information on that. Gladwin can as well, but we can give the capability of programming your parts for you. Giving you some suggestions on fixturing, on tooling, just to make sure that you're fully comfortable using the machine after you purchase it, and that you're set yourself up for success. And we're happy to help you in any way we can. So we're actually going to be doing this exact same thing tomorrow at the same time. In case you want to see it again, maybe there's a question you didn't get the chance to ask, or you just want to show somebody else maybe on your team. But we'll be doing it again. 11 o'clock Eastern, 10 o'clock Central time. And on Friday, we're actually going to have a tapping arm demo. So I did mention the tapping arm here. We're going to showcase some of those features as well. That's going to be on Friday, and that's actually going to be at 1 p.m. Eastern time, noon Central. And that's going to be with Eddie on our team, as well as OSG. So hopefully you can tune into that if you're interested in learning more about the tapping arm. But thanks for coming. We're happy you joined. And like I said, if you have any additional questions that you didn't get the chance to ask, or would like some more information on a time study or a demo or a quote, we're happy to help you out. Gladwin is as well. Reach out to them. They're a great partner of ours. And you know, we hope to work with you again here soon.